Hello and welcome to this video on solving equations. This is the first video on this topic of solving equations, so if you're just starting out, you're in the right place. Firstly, what is an equation? Well, an equation is basically anything that contains an equals sign, like you can see here. So these are all equations. And if we are asked to solve an equation, that means that we are aiming to get a solution. And by that I mean basically an answer. And it must be where you're finding what the value of the letter is. So you're finding the answer for the letter. And the letter on its own. Okay, so you can see here A on its own, Y on its own, not 2C, but just C on its own. What is the value of C on its own? M on its own. That's what we're trying to find. X on its own. And E on its own. So that's what we're trying to do when we are solving equations. Okay, on the screen you can see box plus 3 is equal to 10. Now I'm pretty sure you can all tell me that what is in that box is 7. But how have you actually worked that out? Well, without even thinking about it, in your head you have done 10 minus 3 to give you that answer of 7. So unwittingly, without knowing, you have actually done 10 take away 3 in your head. So I want to look at this in a little bit more detail because this is actually really crucial to solving equations. So let's just take a little scale here. So this is like a set of weighing scales or balancing scales. And you've got on the left hand side, you've got your box plus 3, and there's the left hand side. And you've got on the right hand side, you've got the 10, there's the 10. And the equal signs in the middle is like the pivot on which those scales sit. And they are balanced. They are balanced. I'm just going to delete the ink here to make it a little bit clearer. So remember, if we are trying to solve an equation, it means that we're trying to find out what this unknown number is here. We're trying to find out what that box is, because just like we started off here, we're trying to find the letter on its own, or in this case, the box on its own. This is what we want to try and find. We want to try and find the value of the box. And I know we've seen that it's 7, but I just want to show you how we arrive at that. So what on this side of the scale, on the left-hand side of the scale, what's getting in the way of that box being on its own? Well, hopefully you can see that what's getting in the way of it is this plus 3. So how can we get rid of that? Well, we can get rid of it by doing the opposite, by taking away the 3. But if I do that to that side, in order to keep my scales balanced, I must do the same to the other side as well. So that's cancelled out. Plus 3 minus 3 cancels out. And if I do 10 take away 3, I'm left with my box being 7. 7 is the value of the box, which we know from the start. But I just wanted to show you how we can get that. So we are subtracting 3, or doing the opposite to what we've got here. So we had a plus 3, we take away 3, but if we do it to one side of the equation, we must do it to the other. So let's have a look at this now algebraically. So I'm just going to rewrite this equation exactly the same, except now you can see that my box is now an x. So I'm going to just put it down here. So now, instead of the box, I've got an X, and in an exam, what you would have to do is you should show that you are subtracting 3 from both sides. And that leaves you with your solution of X on its own being 7. Okay, let's have a look at an example now. So, solve x plus 8 is equal to 15. Now, I know you can probably do this in your head, but I really want you to just watch this example through so that you're getting the idea as to what's going on, because equations can get quite tricky, and as long as you understand the idea of balancing with this one, then you should understand the idea of balancing with some of the more challenging ones. So, remember that the aim of solving equations is to get the letter on its own at the end. So we're trying to get x on its own. Or as you can see on my scale here, I'm trying to get the value of this x here on its own. Well, what's getting in the way of that? All these little plus ones here are getting in the way of that. Okay, but all those plus ones there represent that plus 8 there. And all these obviously represent the 15 here. So how do I get my x on its own? Just this little thing on its own? Well, I can just get rid of these plus 1s. But if I get rid of that plus 1, if I get rid of that, in order to keep my scales balanced, I must also get rid of that one. Otherwise, my scale's not going to be balanced. If I get rid of this one, I must also get rid of that one. And keep going until we've done the same to both sides. And there we are. We've got x now on its own. And what is x equal to? It's equal to what we've got left on the right-hand side, which is 1, 2, 3, 4, 5, 6, 7. 7 is what we've got left on the right-hand side. So x is equal to 7. So how can I write this algebraically? So this is how it would look in an exam if you had x plus 8 is equal to 15. What you should show is that you are doing the opposite operation. So the opposite of plus is minus, so you're subtracting 8. But whatever you do to one side, you must do to the other to keep it all balanced. They cancel each other out because plus 8 and minus 8 cancel out. And I'm left with x on the left, and I'm left with 7 on the right. And the absolutely beautiful thing about equations is that you can always check your answer. So if you've got x is 7 here, you can substitute it back into the original equation. So let's put 7 above here, and let's check. 7 plus 8, does it equal 15? Yes, it does. So I know I've got it right. Okay, example number 2. Solve m minus 4 is equal to 2. So now you can see that I've got some little boxes with -1 or -1 in it. So I've got 4 of those because that's what's on the left-hand side of my equation. I've got m and then I've got -4 here. And on the right-hand side, I've just got my 2 there, which is that 2 there. Oops. So how am I going to find out what m is on its own? Because remember, that is what our aim is. We're trying to find out what m is on its own. So I want this on its own. What's getting in the way of that? Well, this group of 4 little -1s, that's getting in the way of it because I want this on its own. So how can I get rid of those? Well, because they're -1s and they're +1s, I can't quite do the same as what I did on the other example where I just deleted them from both sides, because these are -1s and these are +1s, whereas on the previous one they were +1s on both sides. But what I can do is I can say, well, if they're all -1s, I can kind of counterbalance those by putting on all those. Because +4, 1, 2, 3, 4, is going to cancel with -4, 1, 2, 3, 4. But if I've put that little group of +1s there on that side, I must do the same to this side, okay? So those are the same. Okay, I've just put the same thing on both sides. But here, that group cancelled out with that group because these were plus ones and these were minus ones. So they cancelled each other out. So I'm left with m on its own on this side. And what have I got on the right-hand side? Well, I have got positive 1, 2, 3, 4, 5, 6. I've got positive 6. And let's just look at how that would look in an exam situation. So this is what your equation would look like, and then you should show the examiner that you're doing the opposite operation. You're adding 4, but whatever you do to one side, you must do to the other. So they cancel out, and I'm left with m is equal to 6. And of course, you can always substitute your answer back into the original equation, and you can go 6 minus 4. Does it equal 2? Yes, it does. Okay, example number 3. Solve 3y equals 15. Okay, well, if we think back to our algebraic notation, and you can always watch the video on algebraic notation, 3y equals, is, what does it mean? It means 3 multiplied by y. Okay, 3 multiplied by y. So 3 multiplied by y is equal to 15. Okay, so if I look at my scales here, remember I always want, when I'm solving an equation, to get the letter on its own. So how can I get the letter on its own? Well, y here, I can't just take away those y's, okay? I can't just get rid of the y's on that side. Why can't I do that? I can't just take away the y because, so imagine if that was a y there, I can't just take it away because I haven't got any y's over here, okay? I can't take away a y on this side if I haven't got any y's to take away on that side, okay? So I've only got 3 y's on this side, and I can't take them away to leave them with the 1 y that I need. So what can I do? Well, what I can do instead is I can divide both sides by 3, and I'm just separating these out into 3 groups. So I can divide by 3 on both sides. So I'm dividing it into groups of 3, as you can see here. So if I divide both sides by 3, it's the same as doing this. That is dividing by 3. And what am I left with? Y is equal to 5. Let's have a look at how you'd set this out in an exam. 3y is equal to 15. Y is equal to, well, what have I done to both sides? I have divided by 3. Divided by 3 on both sides. And that leaves me with y is equal to 5. Again, you can always substitute back in your number into there or into here and do 3 times 5. Yes, it equals 15. So hopefully you are seeing now the pattern that is going on, because here, I'm just going to highlight it in blue. So here, if we had a minus 4, we did the opposite. We added 4 to be able to solve this equation. On the previous one, we had a positive 8, and we did the opposite to solve the equation. We did a minus 8. And here, this one, well, this is 3 times y, and we did the opposite. We divided by 3 to get the solution. So you're doing the opposite operation in order to be able to solve. Okay, example 4. So Like I've just said, we're looking at the opposite operation. So remember, 6a means 6 multiplied by a is equal to 54. So in order to be able to get a on its own, I need to do the opposite operation. I need to undo that multiplying by 6. And how do I undo multiplying by 6? I divide by 6. And 54 divided by 6 is 9. So my solution there is a is equal to 9. And again, you can always substitute that number back into here, do 6 times 9, and you would get 54. Example 5. To get to j on its own, if I've got a number attached to it, remember that means 11 times j. To undo that, I divide by 11. Whatever I do to one side, I must do to the other. And I get j is equal to 12. Example 6. Here, now we've got a fraction, and that means e divided by 3 is equal to 6. So how do I get e on its own? I do the opposite function to divide, which is multiply by 3. And whatever I do to one side, I must do to the other. 6 3s are 18. Again, check your answer. You could always check your answer. If that is 18, you can put it back into here and see if it works. 18 divided by 3 is 6. So yes, it works. Example 7. X divided by 4 is 12. So how am I going to get x on its own? I'm going to undo that by doing the opposite to division, which is times. Whatever I do to one side, I must do to the other. So 12 4s are 48. And again, check your answer. If that's 48 there, substitute it back into there and ask yourself, does 48 divided by 4 equal 12? Yes, it does. Example 8, t divided by 12 is 6. To get t on its own, I need to do the opposite operation to dividing by 12. Well, the opposite to dividing by 12 is timesing by 12. Whatever I do to one side, I must do to the other. And 6 12s are 72. And again, always check your answer. If that's 72, substitute it back into there and say 72 divided by 12, does it equal 6? Yes. Okay, here are some equations for you to have a go at solving yourself. So write them out and show what you're doing to both sides to get the letter on its own at the end, the solution to those equations. So pause the video, have a go at those now, and restart the video to see the answers. And here are the answers.